Hi, I'm Luis from Doxia Studio, and welcome to our very first tutorial in Houdini. I've been learning Houdini for the past year, and I want to share with you and with the community my experience and how I have transitioned from other software like Cinema 4D, Processing, and even Unity into Houdini. In these tutorials, I want to show you how you can start using Houdini in your own projects and how you can use the knowledge you already have in this amazing software. But before we start, I want to show you quick tips in Houdini so you won't be afraid as I was at the beginning. I'm going to try and be really fast just to help the beginners. So, we have here our viewport, our object tab, our parameters, and a lot of tabs here on top so you can create cameras, lights, explore effects, and everything else. But to start, I want you to close everything that you don't need. Close that. And for Cinema 4D users, at the start when I didn't like this layout, you can do this. Drag this object tab here above and this parameters tab to the bottom. And you have the same layout as Cinema 4D. If you place a box, for example, you can see our object at the top and the parameters here, just like in Cinema 4D. But to start, and I want to use, and I'm used to use the Houdini layout, just going to close this one, and we have our objects and our parameters. As you may know, the Houdini works with nodes, right? To place a node, you can press tab, and for example, put a sphere. You are going to place a sphere on 0, 0, 0. If you want to change the sphere, you can come here and do like a translate in X axis to units, and voila, simple as that. As you can see, here you have some tools that you can select the object, you can translate, rotate, and scale, and you can do all the three at once with this little object, okay, with this little icon. So in these nodes you can see you have a blue tag and a green tag. The blue tag means this object, this node is visible. If I press on the blue tag to turn it off, you can see the box disappear. If I turn it on, it's visible again. This green tag means you can select the object. Right now you can select both, right? But if I turn off the green tag on the box, we can't select it anymore. Okay, when you create a node, you can go inside each node. To do that, you can double click, and to go up again, you can press this object, okay? Or you can use your keyboard. You press I on your keyboard to go inside, and U to go up. Inside one level, with I, U to go up one level. Inside the node, you can start editing your object, right? And you have those little dots. Each node has some dots, and you can link other nodes to the previous ones. For now, just to explain, we are going to place a transform node and link it. To make the transform visible, again, use this little blue tag. We are just going to stick with the blue tag. I'm not going to explain the other ones for now, just to keep things simple. So right now we have the transform and the box. For example, we put here on the box, on the first, the size is 2, right? On X axis. If I come to the transform and I scale on the X axis again 2, it's going to multiply by 2 this value, okay? So it's like you have this node. The next one you link will add some information to the previous one, and so on. So for now, we are going to stay with that information. Along the tutorials, we are going to explain other things like links, control the viewport, these effects, but for now I want to keep things simple, so let's start the real tutorial. In this tutorial we are going to explore very basic principles in Houdini and create this artwork with just a few nodes. We are going to learn how to scatter points and color them with an image, use very simple Vex programming to edit our points, so you can see Vex is not that complex, and work with a very basic particle system with PopNet. You will see that you can create very complex art with simple nodes in Houdini. Hope you enjoy it. Okay, let's start with our empty project. Let's place a geonode, call it particles, dive in, and then place a grid. Here we are. We are using a square grid because our base image is a square, right? So let's scatter some points. Scatter. Increase the number to 10,000. So we have 10,000 particles scattered along the grid. Let's give some colors. To do that, let's go attribute from map. It's going to use the color from an image. Let's pick our chameleon. Accept. And it's giving the colors to our particles, or points in this case. In order to see the points as spheres, let's place a sphere and then a copy to points. This node will ask for a primitive, in our case a sphere, and then points to copy. Our spheres are way too big, so let's put 0.05 maybe. Okay. Here is our starting point. Let's turn off the wire. Okay, much better. Now, let's get started. Our spheres have all the same scale, right? Have all the same 0.05. But we want to change that. We want to change the scale depending on the color. In our case, to get this result, we need to change the scale depending on the brightness of each color. In order to explain that, let me give you a simple drawing. So we have this brightness from dark to white. So in the dark points we are getting small spheres. In the most white brightness we are going to get bigger spheres. We are going to get the scale changing depending on the brightness. So here will be bigger, 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 bigger. Okay? This is our logic. This is what we want for start. So, back in Houdini, we're going to do that with attributes. This is the most powerful thing for me in Houdini, coming from processing, we're working with class and particles. So here we are going to add a point wrangle. I'm going to explain this really simple. So with point wrangles we can add attributes or data to our points. As you see, our points have position, X, Y, and Z, and color, RGB. And we want to add a scale value, scale data. So we are going to add the scale, and in order for you to understand, we are going to put for now scale equals 5. So we are adding this attribute to every single point. This attribute will work for each point, and now it will change the sphere scale. If I come here and change it to 2, you see the points are getting smaller. See? But we still have the same scale for each particle. In order to work with brightness, because we want to work with brightness for the scale, we need to convert the RGB into another color mode. In our case, hue, saturation and brightness. For that we are going to use HSV, right? Equals RGB, RGB to HSV. And we are going to give the color. Okay. Houdini is going to convert the color of each point to H hue, saturation and value. This value is brightness. So in order for you to understand and be as simple as I can, the brightness or the bright is the z coordination, is the z value of this vector. Okay. If I change this to bright now, to use this value, the brightness value, you'll see the spheres are changing the scale depending on the brightness. Cool, huh? But now we have one problem. You see, there are spheres that are way too small, you can't see them. Because the values are so dark, you can't see them. In order to fix this, we are going to use a fit parameter. For example, float fit size equals to fit. I'm going to explain this before we write the code. So the fit works like this. Fit. We have a value that works from 0 to 1. This is our brightness, right? This is our brightness. But we don't want the scale to change from 0 to 1. We want to change it from 0, 1, 2, maybe 3, for example. The fit function will do this for us. So we come here, create a float, because the fit will give us a float. And the fit function needs a value, in our case the bright, that changes from 0 to 1. And we want to change from 0.1 to 0.6, for example. And now we don't want to work with the bright, we want to work with the fit size. Fit size. As you see, if I increase this one, let me do this, and I change this to 1 so we can see it better. So as you may see, the darker ones are getting 0.5 and not 1 anymore, and the brightest, let me try and find the brightness one here, are 1.6. Okay. But one thing I like to do is, after I finish my code, try to use sliders and input, so I don't need to come here and do the code again. So we'll add as channels, so we can just adjust by using a slider. What I mean is this: we're going to use a float size min. That is it's a channel float size min. Okay. And I'm missing something. And we want a size max, and it's a channel float too. Size max. And here we will change to use those values that it will get from the sliders, as you may see in just a second. Okay. And if we press here this little icon, it will create here two sliders, one for size minimum and size max. If we put here like 0.1 and here 0.5, you see we get the values. So right now we can play with these sliders, and we don't need to go back to this code anymore. Just play with this. This is the power, for me, is the most powerful tool in Houdini, the attribute wrangles, because you can work with different type of geometry. Right now we are using points because we are working with points. And I'm going to increase the scatter points to 50,000. Okay, looks good. With our points, it looks like we are almost there, but we have some problems. Right. Let me try and find. Here it is. Maybe if I increase this point. You see, we have some intersections here. But before we fix that, I'm guessing this value is way too big, and the problem is here. If we are like using a sphere and copy 2 points, and this sphere has a uniform scale 0.05, it's getting this value, dividing it by its value, and giving this result. What I mean is, this one should be always 1, so we just need to adjust these values, okay? Because if we have a p-scale here and then changing that p-scale with this uniform scale, it's going to mess up the next thing we are going to do. So before we do that, fix this to 1 and then adjust this. Let me just put maybe 0.05 and 0.04. Wait, that's missing. Okay, much better. But now we have these problems, right? This intersection between particles. So in order to fix this, we are going to use PopNet. PopNet is used to emit particles and work with particles. For now, we are going to use it in the most simple way. So we are going to dive in PopNet. And before we start, we are going to come to this node, the pop source, and emission type change to all points. So it's going to use our previous points. Okay? You come here. And turn off the guide so we can see the color. The original color and not the guide one. Right now, if I press play, it will emit particles every single frame. But it will be chaotic and we don't want that. So we just want to emit on the first frame, right? We could do, if you come from Cinema 4D and you are used to use keyframes, you could come here, alt click, or use this little button, go to the next frame, change it to 0, and then keyframe again. And it will emit only on the first frame, right? But you are on Houdini now. So in order to do that, to delete a keyframe, press Ctrl and click. Go back to frame 1, press Ctrl, click to delete the keyframe. Because we are in Houdini, and I like to work with less keyframes as possible, we are going to use a statement. We could do the simple statement as this, but I want you to understand what's going on here. So I'm going to write a bigger code, but I hope you will understand better this way. So we are going to use a if statement, okay? And the if statement needs 3 parameters here. First one is what is the statement? In our case, frame number, $f means frame number. If frame number equals to 1, if this statement, if this one is true, where is my... If this statement is true, then give the value 0. If that statement is false, then give the value 0. This will work for example, if you want to emit particles every 30 frames, for example, you could do something simple as this. Okay? For example, if we go to frame 30, you get 1. If we go to 31, you get 0. If we go to 60, you get 1 again. See? That's why I prefer to explain you this. I'm not going really into the statements for now, but for you to understand what that code means is that if this frame number equals to 1, If this is true, give value 1, then 0. Okay. So right now we are emitting on the frame 1 and not anymore. But for now we have the same problems. Our PopNet is doing exactly the same as before, and we want to avoid intersections between particles. For that, we are going to use a pop grains. This node will see each point and avoid collisions between particles around it. For now, it's using the particle separation 0.1. If I press play, it's going to be chaotic, but I'm going to try and show you. You see, the particles are really mad. So for now, instead of using this value, the same scale for each particle, because we don't have that, we don't want that, we are going to uncheck this assume uniform radius. What will it do is it will go get the p-scale value. Let me see if I can show you. It will get the p-scale value for each point and use this value to work on the pop grains on this one. So if I go up, let me do this before. It's going chaotic too, right? Why is that? Because when it finds the intersection, the force value is way too big. If you mouse over the parameter, each parameter on Houdini, you can see a little tip to explain which parameter and what it does. So in this case, the force value is way too big. So we are going to crank it down, maybe to 0.2, no, 0.4. And you'll see it go much smoother, right? Much better. If I go up and use the copy to points to see our spheres, much better, right? Look at this. If you are still getting some intersections, you can wait for the simulation, or you can increase these iteration values to 50. But it's depending on you, so okay. Now it looks good, almost done, but we still have a problem here. You may not see now, but if we had a floor like a grid, increase its value to 2 so it can go farther, you'll see the grid will cut in half each sphere. Why is that? Because each sphere, the point in Y, is 0 in every single point, because we are not changing that. We are only playing with X and Z and the color and scale, not with the Y axis, right? Maybe you like this because you can create bubbles and stuff like that, but I want something similar to this. It looks like the spheres are touching the floor, right? So the big ones you can see they are higher, and you can get these little mountains of spheres. In order to do that, we could do in two ways. Go to the PopNet, add a gravity and a collider with the grid, but that's not for now. I want to keep it simple. So we are going to use again Vex, point wrangles, and change by code this point, this position, position in Y axis. Okay? So before we do that, I want to explain you with a box what we are going to do, because it's simple to explain with a small object than thousands of objects. So we have a box. This is what's happening in our sphere, right? Maybe I can use a sphere, but a box is the same. And we have the size in y. In our sphere's case is the p scale. In order to get the box always on the floor, we need to get this value and divide by 2, right? In our case, 1 divides by 2. Oops. By 2. Okay. It gives 0.5. But if we change this value to 4, we need to update this value to 4. In order to change only in one parameter, we can do copy parameter, paste relative, using the channel, and then divide by 2. What this means is it's getting the value on this channel, size y, and it's going to divide by 2. So if I crank this up, 8 is always going to stay on the floor. So with this logic, we are going to get our spheres. We have the scale, and we are going to divide it by 2, right? So let's go up, delete this node because we don't need it, and we are going to get each scale and divide by 2, right? Point triangle. Let's get the point triangle again, and again get the position, the y position of each point equals to, in our case, p scale divide by 2, right? But this is not going to work just now. Why is that? Because we are working with spheres and points. The p scale means the radius of the point, I mean. So as you see, we're still getting the spheres a little bit below the floor, because the p scale means the radius, so we don't need to divide by 2 because it's already divided, right? So if we do that, voila, every single sphere is on the floor without getting into PopNet and adding gravity and deal with the bounces and stuff like that. But we still have another problem, right? Where should I put this? Above or below the PopNet? It's up to you, but for me, I like to put before the after the PopNet. And why is that? Because, let me explain again. Let me create a layer. We have our spheres. Here's a bigger sphere, and here is a small, right? This sphere is going this way, and at some point this sphere is going to be above the small one. So the force will make it go bounce the small sphere and go up, up, and we don't have gravity on our scene, so we will have like bigger spheres flying around with another small, a big one, another one here, and we don't want that. So in our case, let me go back. If we put the point triangle after the PopNet, what we are doing is this. We are going to avoid intersections. Every single sphere is on the same y, ignoring the p scale, and it's going to collide with everything, but not changing the y position. After the intersections are all done, oops, I'm going to push it down after the PopNet calculations. Okay, so I will avoid the other thing I was saying, the bigger spheres going above the small ones. So it's going to calculate the intersections and then push below. That's what I'm doing here. This is programming because everything is going in order. So first we change the p scale, we avoid intersections, and then push it down to the floor. That's it. And here we have spheres on the floor. And each sphere has a different P scale depending on the color, the brightness of each color. Okay. Of course you could go further with this, but I want to keep simple on this tutorial. In the future we will explore more the PopNet, but for now I want you to explore simple nodes like this and create something so beautiful like this plane of spheres, right? Because if you see, let me get back our, okay. As you may see, our chameleon is getting a lot of deformations. Maybe let me crank it up a bit. Here 5, 6. As you see, the legs and the face is getting a lot of deformations because of the particles, they are moving. You could go further and dive into PopNet and change the velocity over time and everything, but for now we just want to get a clean shot, get a nice render, and that's it. That's it for this tutorial. Before we finish this video, I want to say thank you to all our patrons for supporting us. It is our first month in Patreon and we are already halfway to reach our first goal. Really big thank you. For the new audience, if you want to support us so we can keep doing these tutorials to help you out, check out our Patreon page. For the next tutorial we will create a poll so you can vote for the next theme. We are making tutorials for the community, so you decide what we'll teach next. If you like this tutorial, don't forget to hit the subscribe button. And as you may know, you can download the project file and learn how we render this work with Octane in our Patreon page. Hope you enjoy our first tutorial and see you next week.